Welcome to the Walton Pi. Today we're going to go through a couple examples of derivatives at a point. In the last video we were using the function f of x equals 3x cubed minus 7x squared, and in order to find the tangent line we needed to know what the slope of f of x was at x equals 6. So we needed to know that, and the way that we find that is figuring out what the derivative of f is at x equals 6. So we are going to go through together the process of figuring out what the slope of a function is at a point. So the derivative of f at 6 can be written as two different limits. So we could write this as the limit as h goes to 0 of f of x plus h, f of 6 plus h minus f of 6 all over h. Or we could also write it as the limit as x approaches 6 of f of x minus f of 6 all over x minus 6. So both of these are going to be equivalent ways of figuring out what f prime of 6 is. So let's go through and do the first method. So we're going to use this first one. So we are looking at the limit as h goes to 0 of 3 times 6 plus h cubed minus 7 times 6 plus h squared minus 3 times 6 cubed minus 7 times 6 squared all over h. So continuing this limit, we are going to expand out, cancel terms, and then try and evaluate the limit. So this is going to be the limit as h goes to 0 of, we have 3 times 6 cubed plus 3 times 6 squared h plus 3 times 6h squared plus h cubed minus 7 times 6 squared plus 2 times 6 times h plus h squared, all of that, minus 3 times 6 cubed minus 7 times 6 squared, all over h. Now a couple of these terms are going to cancel. This minus 3 times 6 cubed is going to cancel with this 3 times 6 cubed. And this minus 7 times 6 squared is going to cancel with this 7 times 6 squared. And what we notice is every other term has an h in it. So everything else that is not left has an h, which means we will be able to cancel out an h from everything. So this is going to be equal to the limit as h goes to 0 of, we have 3 times 6 squared h plus 3 times 6h squared plus 3h cubed minus, we have minus 7 times 2 times 6 times h minus 7h squared all over h, which means that this over h will cancel with this, with one of those, leaving that to the power of 2, with that, and then with that one. So what we can do is we can now evaluate this at h equals 0. So this is equal to 9 times 6 squared plus 9 times 6 times 0, because this is an h. Let's see, plus 3 times 0 squared minus, let's see, we have minus 14 times 6 and minus 7 times 0 from an h. So this is going to just be 9 times 36 minus 14 times 6, and this is going to be equal to, let's see, let's see, that's the same thing as 54 times 6 minus 14 times 6. So this is 40 times 6. So this is 240. So that is going to be what, so 240 is what f prime at 6 is equal to. Now, we would have gotten the exact same thing if we had gone through the process using the other limit. So let's do that now. So that is the limit as x approaches 6 of, we have, what was the function again? Alright, 3x, so we got 3x cubed minus 7x squared minus 3 times 6 cubed minus 7 times 6 squared all over x minus 6. Okay. So let's go through this together now. So this is going to be, we have 3 times x cubed minus 6 cubed minus 7 times x squared minus 6 squared all over x minus 6 with the limit out front. Forgot that. So this is the limit as x goes to 6 of 3 times x minus 6 times x squared plus 6x plus 6 squared. Let's see, we got then a minus 7 times x minus 6 times x plus 6 all over x minus 6. As you can tell, that, and that will all cancel. So this is the limit as x goes to 6 of 3 times x squared plus 6x plus 6 squared minus 7 times x plus 6. So this is equal to 3 times 6 squared plus 6 times 6 plus 6 squared minus 7 times 6 plus 6. So this is 3 times, we have 3 36s, so that's 108. Right? 36 is 72 plus 36 is 108, yep. Minus 7 times 12. So this is going to be equal to 324 minus 70 times 70 plus 14 is 84. So 324 minus 84 equals 240. So you see, it doesn't matter which method we go about doing it, we are going to be getting the same value for both limits. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.